Today's topic is vertical and horizontal lines. Hopefully you already realize that vertical is the up and down, okay, and horizontal is the left and right, okay, so sometimes that needs to be said. Our learning targets will be to know the difference between an equation for a vertical line versus a horizontal line, and be able to determine the equation of a line from a graph. So a vertical line is a line that starts, or an equation that starts with x equals, and every x value is the same for every point on the line. So what I mean by that is that if we write the equation for this, it's going to start with an x. Now how can you remember that? Well, v is v for vertical, right? And if you were to make a reflection of v, it kind of looked like an x, right? So I like to tell students that vertical or x is made with a v, so there's one way to remember that x equal lines are vertical lines. Now the alternative is a horizontal line. And these are your more traditional y equals, but it's just going to be y equals a number. The slope is going to be 0. And I'll talk about that in a moment. But how do you remember this? Well, go ahead and draw a y, and then think about what would happen if you rotated it 180 degrees. It would look like a h, right? So a v and x kind of have something in common. A y and an h kind of have something in common. So that's how you can remember the difference between a horizontal equation and a vertical equation. Next page, like I said, this is a lot to write down. So if you're trying to take all the notes right now, I would suggest not, or just maybe writing down some important things and then looking at the completed notes when you're getting ready for a test or a quiz. So let's go ahead and take a look at this horizontal line, and just specifically these points, all right? So this is the point -3, 1, 2, 3, 4, -3, 4, and this is the point 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, and 4. Now I could have chose any point on the line. I just decided to do those points, and I want you to take a look at these and see if you see anything that they may have in common. Is there anything that's alike about those 2 points? And normally in class you'd all be shouting out the answer, right? You can see that the y value is the same. Y value is 4, and that's kind of unique, right? So the y value for this is going to be 4 for every single one of those points. So therefore we can call the equation of this line y equals 4. And that's it. Now the reason for that is because the slope is 0. All right. I'm going to take this round object, this marker right here. I'm going to set it on this flat desk. And guess what? That marker didn't go anywhere. It's kind of hard for you to see, but it's laying on the desk. And the reason why? It's got no slope. It's got 0 slope, that is. 0 slope. Now, if I was to pick up the desk, all right, boom, off the paper or off the table it goes. But right now, a flat surface like the floor you're sitting on has 0 slope. And so that's why we would not, write mx or any part of it. Next line is a vertical line. So same thing. Let's take 2 points. We could have chosen any 2 points. I decided to go with these 2. And let's look at the point 2, down 1, -1, and this point 2 and up 1, 2, 3, 4. All right. So the 2 points are 2, 4, and 2, -1. And looking at those, do you see anything that they may have in common? 2's, right? Yeah, good. So they both have a 2, and it's in the x value. So x value is both 2. So how do you write the equation of a line? For a line that is vertical, remember, it's a v with an upside down v, so it's an x, and then the value would simply be 2. So x equals 2, and that's it, all right? It's a Friday, easy lesson, easy topic. So don't get overconfident though, because we're going to put some things in here that might make it a little bit confusing, but for the most part, not too bad. All right, not really, John. Not really. All right, buddy. But if it does, you let me know and I'll answer any questions you may have, okay? Now, I wouldn't say walk away from the computer right now, because we are going to do some things that are a little different, like write an equation from a point. And you're like, is that enough information? Well, if I tell you what type of line it certainly is. So if it's a vertical line that passes through the point 5, -3, underlining, annotating, always a great idea. The vertical line would be x equals, right? So you know that. Now, which one of those numbers do you steal? The x value. So x equals 5. So a lot of common sense here when you're writing out these equations. The next one, write an equation of a horizontal line that passes through the point x, y. Horizontal line that passes through the same point, 5, -3. This time it starts with the y equals, remember the upside down h, and we steal the y value of -3. Okay? So any questions, let me know, but it seems like things are going pretty well. Next page. Now we got to be able to do it from a graph, and this is why I said don't walk away, because it's important that you can do it in all different facets. So this time, I'm just going to look at the line and start the equation. For instance, vertical line, x equals. Vertical line, x equals. Horizontal line, y equals. It's as easy as that. I can tell that just by looking at the lines. Now, what about the number? That's all I need. All that's left is a number. Well, in this case, the line is according from 0, 1, 2, 3, so it's +3. In this case, the line is 1, 2, 3, 4, -4. And in this one, if that's 0, it's down 1, so it's -1. And that's it. That's all it will take to write these equations. For the next few, I'm going to ask a few people in the audience to share their microphones like we did a little bit earlier and tell me what this equation would start with. Letter D, who's, feeling confident and think they know what that will start with? Yes, for the first one, if this is x equals 1, 2, 3, 4, 5, so +5. This one, if this is 0, would be up 1, 2, 3, 4. And this one here would be up 2, so y would equal 2. All right, there you have it. Being able to come up with an equation just by looking at the graph. Now notice these are not diagonals, so we don't need a slope and a y-intercept. We just need how far it is from 0. All right, we're going to keep things moving here. And this is one that you're definitely going to want to wake up for, okay? So the equation of a line passing through the point -4, 5 that is parallel to the x-axis. No picture drawn. And so whenever there's no picture drawn, I need a visual. I'm a visual type of person, so I'm going to quickly do a y and an x-axis. Now, just like I asked for your homework on practice number 9, you can only sketch these, okay? So you can approximate the y-intercept, whether it's up or down, above or below 0, or you can kind of say the slope is negative or the slope is positive. You can't exactly draw an accurate one, all right? So I'm going to plot the point -4, 5. So -4 would be left, up 5 would be right about here. And then it says the line is parallel to the x-axis. Now, we got to remember what parallel means. Hopefully this is something you already know, but it means they'll never cross, all right? They'll never intersect, two lines that will never meet. So parallel to x means it can't cross x, so it's got to be a horizontal line, all right? I want to say horizontal line, it's a y, because a y kind of looks like an H, right? If I didn't give it so much of a tail, it would look like an H or horizontal line. So this is y equals, and what is the number? Well, if this is the x value and this is the y value, steal the y value, okay? Let's try this again. This time, it's an equation of a line that passes through the point 3, 2, but it's perpendicular to the x-axis. So if parallel goes like this, perpendicular goes like this, all right? It makes a T and it crosses. So where is it going to cross? Well, 3, 2 is the point that it goes through, something like that, and it's perpendicular, so it crosses through the x-axis. I wanted to make that a different color, so I will. and it makes a right angle if you're being particular. And now we need to come up with the equation of the line. An x equals line, because it's a vertical line, and so let's go up to the point that it went through. There's the x value, there's the y value. It's going to be x equals 3. So there you have it. So a little information about horizontal, vertical, perpendicular, parallel. A lot of vocab here, but hopefully it's stuff that we know and we're successful with. I've got one more slide, and this one last slide is going to review solving linear equations into slope intercept form. So if this was a problem for you, if you didn't show the work for the homework and you have to redo it, or if you didn't do practice number 9, this is the quick review that you'll get from the previous lesson. So tune me in here. We need to put these into slope intercept form before graphing. We cannot identify the slope or the y-intercept unless y is by itself, and none of these have that. So the first one, we subtract 8 on both sides. We're going to get 2y equaling, unlike terms, cannot be subtracted, so 4x minus 8. Very important that you do not try to add or subtract terms that are not alike. Next up, I want to undo the multiplication with division. Now I did catch a few of you not dividing everything by 2. Even this number that maybe can't be divided by 2 needs to be divided by 2. And when we have to, leave it as a fraction. All right, we'd rather have this as a fraction than a decimal. I did see a few of you putting decimals down. Once we have that, we can go ahead and say that the slope is 2 over 1 and the y-intercept is -4. From there, we go over to the graph. Now again, if you don't have a graph, you know where 0 is, even if there was no grid, that is. But you could put a y and x-axis down and simply go below 0 for a -4 y-intercept. And then from there, it's a positive slope. So it's going to rise and run 2 and 1. I have the grid lines to be able to plot the points, but if you did not, you can just simply make sure your slope is positive and it has a negative y-intercept. Don't forget to extend the lines, put arrows on it, and seal the deal, all right, with its label. So make sure you do all those things to complete the process. Next up is another equation where I have to solve for y. So if I'm solving for y, I'm going to want to move 3x. Now I'm going to want to do that to both sides, okay? The reason why I did that is to get this to go away. Goodbye to you. Y is by itself. Now think carefully. 3 minus 3. 3 minus 3 is simply 0. So 0x plus 2. And this is a great example, the thing that I've been talking about from the beginning, of what zero slope means, okay? The flat table, right, has no slope. This equation has no slope. And guess what? Do I need to write 0x if 0 times anything is 0? I do not. So that's why these only are written as y equals 2. You don't need an m value. You don't need a slope. So what you're going to do is go up 2 on the y-axis, 1, 2. All right, and once you do that, you remember that a y equals is a horizontal line that goes across the page. So there it is, y equals 2. Last one, and I'm not getting any questions. If you do have questions, please let me know. Has only x in the equation, and you've solved a gazillion of these. Did you ever know you could graph it? Probably not. So I'm going to start the way I always start, by adding 8 on both sides. 3x equals, these are like terms, so I can subtract -11 and 8 to get -3. I'm going to divide by 3, and x is going to be -1. So typically, when you get to this far, you're done, right? I solved for the variable, nothing left to do. But when there's a piece of graph paper sitting next to you, now it's time to go from 0, 1 to the left. So I want to put that point on the x-axis at -1, and I need to remember that an x is made from a v, as in vertical. So a vertical line goes in, extended, arrows on it, and labeled x equals -1. All right.